So this is the 3-tier architecture that we are going to demonstrate. So in this architecture, we have a VPC. We have divided our infrastructure across 3 availability zones: availability zone A, B, and C. We have divided our subnets into 4 segments. One is public web subnet, the second one is private web subnet, the third one is private app subnets, and the last one is private DB subnets. So the public web subnets will have the front-end ALBs, which will be exposed to the internet. The private web subnets will have the front-end servers in the auto-scaling group. The private app subnets will have the backend ALB as well as the backend servers, which will be in the auto-scaling group. And finally, the private DB subnets will have databases. To create this particular architecture, we will have to go through these steps. So initially we will create a VPC, then we will create subnets. Up next, we will create route tables. After that, we will associate the route tables with the corresponding subnets. Then we will create the internet gateway, attach it to the VPC. Then we will create the NAT gateway in the web public subnet. Then we will add the internet gateway and the NAT gateway routes in the route table. We will have an internet gateway route in the public subnet route table, and we will have a NAT gateway route in the private subnet route tables. After that, we will create security groups. Once the security groups are done, we will create the database subnet group. Then we will create the database server in the RDS. After that, we will create the front-end ALB instance. Then we will create the backend ALB. Once that is done, we will create the front-end server AMI. Then we will create the backend server AMI. Once the AMIs are done, we will create the launch template for the front-end server. Then we will create the launch template for the backend server. Then we will create the auto-scaling group for the front-end server. And finally, we will create the auto-scaling group for the backend server. So once the entire infrastructure is provisioned, we will finally test the application on our Chrome browser. I'll quickly walk you through to the code as well. So our code is divided into 4 folders: front end, back end, the database, and the infrastructure. The front end folder consists of index.html. It contains the JavaScript code as well, and it has a styles.css to beautify your HTML. Moving on to backend, it has a folder called API. In API folder, we have 3 files: get messages to extract all the messages from your database. We have save message, which will save the message on your database, and the DB connection, which holds the connection string. Moving on to database, it has a database setup script, which will create a demo database for us, and it will insert few rows for us. So under the infrastructure folder, we have 3 files: the frontend server.md, the backend server.md. The frontend server contains all the steps that are required to be installed on our frontend server. Likewise, the backend server.md contains all the steps that are required to be done on our backend instance. And finally, it has a nginx conf file, which we will see once we install our nginx server on our frontend servers. So this completes our code base. It is just a simple hello world 3-tier application. However, I have divided the front end, the back end, and the database into loosely coupled systems. So we will have our front end in the front end servers, we will have backend in our backend servers, and we will have a separate database. So that will complete our 3-tier architecture. So we have seen the architecture, we have seen all the steps that are required to create this infrastructure. We have done a walkthrough through the code. Now finally, let's jump onto the AWS console. So let's go step by step. The first step is to create the VPC. We'll go to the VPC screen. Create VPC. Instead of using the interface, let's create the VPC the hard way. So let's give a name, demo VPC. Let's keep IPv4 CIDR manual input as same. Let's add the IPv4 CIDR. I already have the CIDR with me. So it is 10.0.0.0/16. I'll keep rest of the options as is and create VPC. Once the VPC is created, we'll move on to creating the subnets. So here we are on the subnet creation screen. I will select demo VPC. I'll give a name as demo web public subnet 1A. I will select US East 1A. CIDR range as 10.0.0.0/20. I have listed all the CIDR ranges on my architecture diagram, so you guys can refer that. So on the same screen, we will try to create rest of the subnets. So I will copy the nomenclature 1B, availability zone as US East 1B, CIDR block as 10.0.16.0/20. Again, I'll copy this subnet name. (32.0/20). So this completes our public subnets. I will move on to web private subnets. Let me check if I have selected the right availability zones. Yeah. (10.0.48.0/20). Select 1B, CIDR range as 64, 10.0.64.0/20. Add a new subnet, the final web private subnet. We will select US East 1C, CIDR range as 10.0.80.0/20. Moving on to the app subnets. Instead of web, we will say app private 1A 10.96.0 10.0.96.0/20. Select 1A. One B 11 10.0.1120 10.0.1120/20. One C. Select the C. (10.0.128.0/20). Moving on to the final segment of the subnets, we'll create the DB private subnets. (10.0.144.0/20). One B 10.0.160.0/20, and the final subnet, that is demo DB private subnet 1C. We will select the 1C availability zone. I'll add the CIDR block 10.0.176.0/20. Let me quickly validate web public subnet 1A. Everything looks good, so I'll quickly create all these subnets. We have created 12 subnets, 3 web public, 3 web private, 3 app private, and 3 DB private. So all these subnets are created. We will quickly move on to the next step, that is creating the route tables. In case of route tables, the public subnet will have only one route table, whereas the private subnets will have one route table for each. So let's quickly move on to creating the route tables. So we will create the demo web public route table. Create route table. So we will select the demo VPC, create the route table, create the 3 route tables for web private subnets. Copy this. Moving on to app private, let's create 3 route tables. Create the remaining route tables for app private. And finally the last route table for app private. Now move on to the DB private route tables. Let's quickly validate if we have created all the route tables. So 1 public, 3 web private, 3 DB private, and 3 app private. Now the question arises why we have created so many route tables. When you talk about best practices in terms of scale and security, it is always better to have one corresponding route table for each subnet, because if moving on we want to create multiple NAT gateways, it becomes really easy to tag one NAT gateway to a single route table. So we have created the VPC, we have created the subnets, we have created the route tables. Now let's associate the route tables with each subnet. So we are already in the route table screen. So I'll select the only public route table. I'll select the tab subnet association. I'll associate all 3 public subnets with this particular route table and we'll save the association. So you will see under subnet associations. Moving on, let's start with the web private subnets. So we will select web private and the 1C, because we have selected 1C first. So if you see the subnet association, you will see it as associated. Moving on, let's associate 1B. Let's associate 1A. Web private, save association. Similarly, let's do for app private first. I'll select 1A. I'll complete it for 1B and 1C. App 1C. And finally, moving on to the DB private subnets, let's associate each one. So let's quickly validate if the associations are correct. So usually with the new console, you can create VPCs and subnets quite easily with the wizard, but I wanted to demonstrate it the hard way and wanted you guys to understand the networking piece of the 3-tier architecture as well. And also I wanted to create 12 subnets, that is the web public, web private, app private and DB private, which was not possible through the wizard. So that's why I wanted to do it manually from the VPC console. So moving on, we have associated the route tables with corresponding subnets as well. Now we will create the internet gateway and the NAT gateway. So let's give it a name, demo internet gateway. Click create, and we will also quickly create the NAT gateway. So this is a very important step that many people kind of miss, and I have taken numerous interviews. People are often confused in which subnet we have the NAT gateway. So NAT gateway is always deployed in your public subnet. So let's select any public subnet. So we will select public subnet 1A. I'll associate the elastic IP and create the NAT gateway. For this demo, I have created a single NAT gateway, but if you are on a production workload, it is always recommended to have one NAT gateway for each private subnet or each availability zone, so that you are safe, and in case of a availability zone failure, your outgoing network connectivity is not stopped. So moving on, let me check the internet gateway. The internet gateway is created, but you can see that it is in the detached mode. So I will attach it to the VPC. I've attached to the demo VPC. So the internet gateway is created. Let's quickly check if NAT gateway is provisioned. So now here I see that it has failed, and let's check why it is failed. So while we were creating the internet gateway and attaching, I had also started the NAT gateway creation process. So it has failed. So now our internet gateway is attached to the VPC. So I'll create this particular NAT gateway again because it was failed. So a very critical learning here is, if you want to create a NAT gateway, you have to wait for the attachment of the internet gateway with the VPC, then only a NAT gateway will be created. So again, I'll select the public subnet. For now I'm selecting 1A. The elastic IP was already provisioned, so I'll create the NAT gateway. Now let's see if this NAT gateway provisions. It is still in the pending state. Let's wait for a couple of minutes for this NAT gateway to come up, then we will proceed with the remaining steps. Yeah, so we can see that the NAT gateway is in now available state. Okay, so we have provisioned the internet gateway and the NAT gateway. Now we have to add those routes in our route tables, both for public as well as private route tables. So let's go back again to your AWS screen. So under route tables, I will first select the public route table. Under routes, I will edit the routes. For this, I will add the internet gateway, since this is the public subnet. Similarly, for all private route tables, I will select the NAT gateway, because we want to have outgoing internet access to all our private subnets. So let me check what was the ID of the NAT gateway which was created. If you remember, one NAT gateway had failed, so it is ending with B6. I'll close this and select B6, save changes. Select route tables again. I'll quickly do for the rest of the subnets and the route tables. NAT gateway B6, save. So many people might argue that I have done a lot of things manually, right? But if you don't do these things manually as a cloud engineer, it will be very difficult for you to automate these things. You can do, or maybe you can work on a lot of automation only and only if you do it manually. So the objective behind this video is to help people to create this infrastructure manually. Once you are comfortable with manual, the next step we will do is create this entire infrastructure using Terraform code. So be rest assured that this is not the best practice. People do not create the entire infrastructure manually on production systems, but it is very important for you guys to understand how things are implemented manually. So even before jumping on to automation, we have to do things the manual way as well. I'll quickly complete remaining stuff. Yeah, I think I have completed all, but let me quickly check. routes. Yes, I think we have done all. So for our public route table, we have associated the internet gateway, and for our private subnets and route tables, we have associated the NAT gateway for all outgoing internet connectivity. Yeah, so I think we have completed all the networking piece. So before we jump into the security groups, let's quickly revise what all things we have done so far. So we have created a VPC. So we have created 12 subnets, 3 web public subnets, 3 web private subnets, 3 app private subnets, and 3 DB private subnets. We have created a single route table because there is only one internet gateway and it will be connected across all 3 public subnets. So we have created a single route table. As discussed earlier, I have created separate route tables for each private subnet. So I've done 3 private subnets, 3 app private subnets, and 3 database private subnets. Moving on, we have associated all the route tables with corresponding subnets. Then we have created the internet gateway. We have created the NAT gateway. We have added the internet gateway entry in the public route table, and we have added the NAT gateway entry in all the private route tables so that it can get outgoing internet connectivity. So we have completed the networking piece. Now let's get into the security groups. So as per the diagram, we will need security groups for frontend ALB, frontend servers, backend ALB, backend servers, and database servers. So let's create security groups one by one. Security groups, demo, front end, ALB, SG. I'll copy the same thing. I'll select demo VPC. Under the inbound rule, I will add port 80, the HTTP port, and I want to allow the entire internet to access the front-end ALB server. So I'll give the description as from the internet. So I'll leave outbound as is and create the security group. Let's create the front-end server security group. Here I will add again port 80. However, the request to the front-end servers will come from the ALB. So I'll select the front-end ALB security group. I'll mention from front-end ALB, create security group. So we have created security groups for front-end ALB, for front-end servers. Now we'll create for back-end ALB. Demo backend ALB security group. Select the VPC, port 80. Now for this, the source would be your web servers or the front-end servers. So let's select from save. Moving on, let's create the security group for the backend servers. again the port would be 80. For this, the source would be ALB backend. Create it. And finally, let's create the database security group. So demo database security group. The range would be 3306 because MySQL listens on 3306, and it would be the backend servers. Let's create the security group. So as per our steps, we have created all the security groups. Now we have to create the subnet group for the RDS database. So for that, let's go to RDS. Go to subnet groups, click on create DB subnet group, demo database subnet group. Select the demo VPC. Now here we have to select 3 availability zones, 1B and C. And here we have to select carefully only the database subnets. So DB1B and DB1C. So DB and DB, yeah. So let's create. So the subnet group is created. Now we have to create the actual database. Let's go to databases, create database. I'll choose standard create for now. I'll select MySQL. Show only version that support. This is okay. MySQL version is okay. I will select dev test. In the architecture, I have shown multi-AZ. So for the sake of it, let's select multi-AZ with 2 instances. Demo database. I will keep the username as admin. I will have a self-managed password for now. As a best practice, it is always recommended to have it in the AWS Secrets Manager. But the purpose of this particular video is to simplify a 3-tier architecture. In the coming weeks, maybe I can cover the Secrets Manager as well. But for this particular video, I want to keep it really simple. So I will type the password of my choice. I will confirm the password. Under instance configuration, so I will select the burstable classes which are usually cheap. So I will select dbt3 micro. Allocated storage, I don't want 200, so I will keep it as 20, which is the bare minimum. For connectivity, if you remember, we have already created a security group and allowed access from the app server to the database server. So for now, I'll leave it as don't connect because we have already done that particular thing. We will select the demo VPC. The demo database subnet group is already selected. Public access is no. As a best practice, it is recommended for all your database instance to be always in your private subnets, and there should not be any public access. So we have already created the security group. So I will select the demo SG security group. I don't want a RDS proxy right now. Certificate authority is fine. We have selected password authentication for now, but if you want, or if you have a use case, we can do IAM based authentication as well. But I have chosen password authentication for now. Database insights is fine. This is fine. I don't want to have any logs for this particular demo. So it is going to cost me this many dollars. But as soon as this particular demo is done, I am going to terminate all the instances. So I will quickly create the database. So meanwhile the database is being provisioned, let's go to EC2 and create the application load balancer for the front end server and for the backend servers. Let's go to load balancer, create the load balancer, select application load balancer. Load balancer name can be demo front end ALB. It should be internet facing because all the traffic is going to come from the internet. This is fine. Network mapping, let's select demo VPC. Let's select all 3 availability zones as per the best practice. Let's select public subnets because these particular instances needs to be in the public subnet so that it is accessible from the internet. Security group we have already created, so let's select that. So under listeners and routing, we have to create a target group, but we are not going to attach any instances in the target group because we are going to create the instances in the auto scaling group. So let's quickly create an empty target group. So I'll select instances. Target group name can be demo front end ALB target group. Port is 80, that is fine. VPC is demo VPC. Health checks is fine. Let's click on next. As I mentioned earlier, I don't want to register any instances as of now because we want to add all the instances dynamically using the auto scaling group. Let's create the target group. So once it is done, let's close the window. Let's do a quick refresh and yeah, you will see that the target group is being added. I don't want to add any CloudFront or WAF as of now. Yeah, maybe quickly validate everything. Public and create the load balancer. So this will take some more time and we will create the backend load balancer as well. Give it a name demo backend load balancer. It cannot be internet facing because we already have a public facing load balancer. So I have kept it as internal. I'll select demo VPC. I'll select all 3 availability zones as we did for front end ALB. Now we have to select the subnet carefully. So this is a private load balancer which is going to expose your application servers. So we will select app subnets. So all 3 app subnets are selected. We will select the demo backend ALBSG. Again, we will have to create the target group. We'll keep it as instances. We'll have to give a target group name. Target group. Rest of the details are fine. Let's keep available instances as is, and finally create the target group. Let's close the window and refresh it. Yeah, so we'll see demo backend ALB target group. Let's keep rest of the things as is. Let's quickly validate app and app. Yeah, let's create the load balancer. So we have provisioned both the load balancers. So as per the steps, we have created the database server, both the load balancers and corresponding target groups. Let's see if these are being provisioned. Okay, let's quickly check if the RDS instance is also provisioned. It is still in modifying status. Now that our front-end ALB and backend ALBs are created along with their respective target groups, let's get going with the AMI creation. Okay, so we'll first create the front-end server AMI and then we will create the backend server AMI. So for the front-end server AMI, we will require Nginx and we will require Git. And for the backend server AMI, we will require PHP, MySQL, Apache, and we will install Git, and then we will run the database script. So let's get into the AWS console and get started. So let's launch the front-end AMI server. Let's select Amazon 2023, that is fine. Let's create a new key pair. Front end. Select the existing security group which we had created earlier. But before that, let's select the demo VPC. Let's create the instance in the public subnet. So I'm selecting public subnet for this particular instance is because we are going to just create this instance, and then out of this instance we are going to create an AMI. So once the AMI is done, we are going to terminate the instance. So that's why I'm choosing the public subnet for now. So let's enable the public IP auto assign. Select the existing security group. Rest of the things looks okay. Let's launch the instance. Let's launch the backend instance as well. Let's keep instance type as same. Demo backend. Let's create the key. Under the network settings, let's select the demo VPC. As discussed earlier, let's select the public subnet as this instance is going to get terminated. So it's okay to keep it as public. Once the AMI is done, we are going to get rid of these instances. Select the existing security group. This is fine. And launch instance. Yeah, so both the instances are now in the initializing state. So let's try connecting the instance. Let's try the other one as well. Okay, so now it says error establishing SSH connection to your instance. Maybe that is because while creating the security groups, we have not added the port 22, right? Because this particular backend and front-end instances are not supposed to be exposed over the internet, but since we are creating the AMIs on a temporary basis, what we will do is let's go to security groups and temporarily add the SSH rule. Once our AMIs are done, we will get rid of that particular SSH rule. So let's edit the inbound rules, add port 22 and for the internet. So let's give it a description that it is to be deleted. Similarly, we will have to also do for the other security group. Add port 22, temp to be deleted. Okay, now let's try refreshing both the instances and see if we are able to connect. Yeah. Okay, so let me check which one of the server is front end and which one is the back end. So the front end one is ending with 154. So this is the front end and this is the back end. So in the front, okay, so in the front end server, we have to install Git and install Nginx. So let's get into infrastructure folder. Let's get into front end. Let's copy this. So this will install the Nginx server. And install Git. Okay, so both Nginx and Git is installed. So now we have to replace the server block in the Nginx conf file with the contents given in the Nginx config file in the infrastructure folder. So let's copy this server block. Let's get into that particular file, nginx.conf. So we have to comment out the existing server directive or the server block. So once done, let's add our configuration just after what we have commented. Let's save it. Let's see whether the changes are there. Yeah, so now we can see the changes. Let's quit. Let's go back to the documentation. Okay, so we have installed both Nginx Git and we have also replaced the server block with the content from the Nginx conf that we have in the documentation. So once both the AMIs are done, we will launch the template and add the EC2 user data while launching the template. So we will talk about that later once we create the launch template. So similarly, we have to perform the installation steps for the backend server. So let's go to this documentation and install PHP, Apache and MySQL. Let's do this. So this will install PHP, Apache and MySQL utilities. Yeah, so that is done. So we will also install the MariaDB server. We are installing just for the SQL client. We are not going to enable the MariaDB server instance. Let's start the Apache. Let's enable HTTPD. This is fine. Let's change the permissions. Let's change the ownership of the www folders. I don't want to install any PHP info or maybe create any PHP info file for that. So let's ignore rest of the steps. I don't want to create the database server as well because we have already provisioned the RDS instance. So let's ignore rest of the steps and go to the documentation. So we have installed PHP, Apache and MySQL client. Let's do the Git as well. Okay, so Nginx and Git is installed in your front-end server, and PHP, Apache, MySQL and Git is installed in our PHP server. So there is an additional step in our backend server or backend server AMI that we have to do. So after installing PHP, MySQL, Apache and Git, we have to also run the database script. So this database script is in the database folder. Here we will get the database script. So before that, we will have to connect with the MySQL. So let's get into RDS. Copy the endpoint. So let's log into the database instance from our backend AMI instance. So we have copied the database host. The username is admin-p. So I'll punch in the password. So we have logged into the MySQL instance. So let's go to the documentation and copy the command. So what this script will do is it will create the database, it will create the table, and it will insert few sample rows for you. Okay, so once done, let's exit from here. So this completes our installation steps required on the front end and the backend AMI. So let's do one thing. Let's stop both these AMIs or stop both these instances, and we have to create AMIs out of these instances. Okay, so let's stop these instances for now. So both the instances are now stopped. Let's create AMIs out of these instances. So I'll keep the same name, demo frontend server AMI, and create the image. Similarly, I will create the image for backend as well. Again, let's keep the name as same, create image. So let's wait for these images to get completed. Yeah, so both the AMIs are now complete. Now let's move to the next step, that is creation of the launch template. So we have completed the AMI creation. Now let's move on to launch template. So let's create a launch template. Give it a name, demo frontend server launch template. The template version can be 1. Select my AMIs. Select the front end AMI. Instance type, I don't want to include it as of now. Key pair, we already have a key pair, so let's select that. Front end key pair. Security group, we already have a security group, so let's select that. Demo front end server security group. Storage is fine. Very important to add the user data script in the advanced detail section. So let's copy the user data script from our documentation. So let's copy that. And if you see here, you have to insert the load balancer URL here. So let's go to EC2 instances and go to your load balancers. Copy the DNS name for the backend load balancer and paste it here. So it is really important to paste the backend load balancer DNS name here, because your Nginx instance is going to connect to the backend load balancer. So once this is done, let's run the create launch template button. Similarly, let's create the launch template for backend as well. Again, the template version can be 1. Under my AMIs, we have to choose the backend server AMI. Instance type, I don't want to specify anything. Let's choose the backend server key. Security groups can be the one which we have already created, backend server SG. Storage is fine, resource tag is fine. Again, under the advanced details tab, we have to add the user data script that we have in the documentation. So let's copy that, paste it here. Here we have to make changes to the script. We have to add the host name over here. So let's go to RDS. DB instances, demo database. Let's copy the endpoint. Let's update the host name carefully. Let's update the username as well. And finally, let's update the password here as well. So don't worry too much about the password being seen over here in the user data script as of now. The idea behind this exercise or the demo is to help you understand what a 3-tier architecture is and how do you implement a 3-tier architecture in a very basic way on AWS. So moving forward, we can also look after the security aspect as well. But as of now, we don't have to think too much about security. The idea is to learn the AWS 3-tier architecture. So let's ignore the security aspect as of now. And then let's create the launch template. So what this particular user data script will do is it will update the host name, the username and the password in your code, in your backend code. So we already have a backend code in your API folder. If you see the DB connection, we have these things which are templatized. So as soon as the auto scaling group triggers, it will update the username, update the host and update the password. So the idea behind having this is I wanted to keep the credentials or the parameters outside of the AMI. Okay, so as a best practice, we have to keep our credentials or parameters outside of the AMI, so that your AMI is not tightly coupled with your application. So this particular AMI, the Nginx or the Apache AMI, can be used in other applications as well. So that was the idea behind having this host name, username and password in a templatized fashion and getting replaced in a user data script. Right, so both the launch templates are provisioned. Now let's go to auto scaling groups. Create the auto scaling group. Let's give it a name, demo frontend server auto scaling group. Select the launch template that we created. These details seems okay. I don't want to specify the instance attributes. Let's keep it simple and manually add the instance type. Let me select T3 micro. I don't want to have any additional instance types. So let me delete all these. Instance purchase option is fine. Allocation strategy is fine. Network, I have to choose demo VPC. Subnets, I have to choose the private web subnets. So I will choose the private web subnets. This is okay. Click on next. I already have created the load balancer. So let's choose the corresponding target group. VPC lattice integration options is fine for now. Health checks is fine. Let's click on next. Let's keep the desired capacity as 2. Let's keep min desired capacity as 2 and max as 4. Let's keep the target scaling policy as average CPU utilization as 50. Instance maintenance policy is fine. Additional capacity settings is fine. Click on next. Notification, I don't want to keep anything as of now. Tags, let's add demo frontend server. Next. Everything looks okay. And let's hit create auto scaling group. So what this will do is it will trigger the auto scaling group and create couple of instances for us with the Nginx AMI that we have created in the previous step. So similarly, let's create the auto scaling group for the backend instance as well. So let's create the, so let's select the demo backend launch template. Click on next. Manually add instance types. T3 micro. I don't want to have any additional instance classes to overcomplicate it, so I'm removing that. Instance purchase option is fine. Allocation strategy is fine. Network, we have to choose demo VPC. Again, availability zone, we have to choose app subnets because our backend subnets, backend server instances are in the app subnets. Availability zone shift is fine. Attached to an existing load balancer. Select the target group. VPC lattice is fine. Application recovery controller and health checks is fine. Click on next. Again, the capacity as 2, min as 2 and max as 4. Target scaling policy as average CPU utilization 50%. Everything else looks okay. Notification I don't want to have. tags demo backend server. Click on next, and finally create auto scaling group. So again, what this will do is again create couple of EC2 instances. So here we see that front-end servers are being provisioned and the backend servers are also being provisioned. Let's check if it has picked up the user data. Yes, this looks okay. This is being replaced. This looks okay. Let's check for the backend as well. Under instance settings, let's check user data. Yeah, so host was replaced, user was replaced, and password was replaced. Okay, perfect. Okay, so let's go to your load balancer. Click the DNS name for front end, and let's try hitting what happens. Let's see. Okay, cool. So we can see the messages from the database. Let's try to add something. Cool. So this particular text is also being populated. Okay. So what happened when I hit the URL demo frontend ALB? The request got into the frontend ALB instance. From there, it was distributed to the private web server instances, where it fetched the HTML, CSS and JavaScript. It loaded that and it triggered a API request to the backend instances via your backend ALB. So the request got into the backend ALB and it was distributed to your backend servers, where exactly the business logic was written to fetch the data from your database. And that is how you are able to see your messages from your database. So this is what a typical 3-tier architecture looks like, where your front end is separate, your backend is separate, and your database is separate. Okay, thank you so much for watching right till the end. If you have any questions, please let me know in the comment section.